Okay, so let me quickly go down. As I've said, I'm going to use Hunza questions. I'm going to use Hunza sample questions. So these questions are coming from Hunza. So these questions, I got them from Hunza. So that means that these are very important questions that each one of us is supposed to really know and know how to go about it. Yeah, how to go about it, just in case you don't know how to slang. All right, so as I've said, there are two types of limits. There is finite limit and finite limit and infinite limits. Okay, so I'm not going to waste much time. I'm going to focus much on the explanation. Okay, so evaluate the limits. The first question which we have here, evaluate the limits, and it is saying lim x approaches 2, meaning in this case we are approaching x from both the left hand side and the right hand side. Okay, so we are approaching the limit from both the left hand side and the right hand side. So the question is saying evaluate the limits whereby this expression you are approaching x from the left and from the right. Okay, so that's our expression, our first expression. Okay, our second expression is also asking us the same thing. Evaluate the limit where x is approaching 3 from both the left and the right hand side, from both the left and the right hand side. Okay, so let me just quickly check up if at all I'm audible on our Facebook page, and then I'll be able to solve these questions. So please, in case you have challenges, make sure that you comment or you screenshot and send the question in my inbox, and I'll be able to attend to you. Okay, so I can see I'm audible also on our page. So the third question, it is saying lim x is approaching infinity. Okay, this x of ours is approaching infinity. Okay, and then it is coming from the it's infinity. So this one, it is infinite type of limit, and that one is infinity, and the other one it is infinity. Okay, so let me go down. All right, I think there we can now start solving. I don't know if everyone has seen the questions. So I'm having two type of questions, 2 questions from infinity and 2 questions from finity. Okay, so I'll quickly do my work and I'll just say solution. Yeah, I'll just write solution there. I do believe we can all see the solution part, the solution right there, because some of us, we might not see it. So the first thing, I'll start with the first question. Which is lim x approaches 2, lim x approaches 2, lim x approaches 2. That means that we are approaching this expression or this function from the left and right side of 2. Okay, we are approaching this expression from left and right hand side of 2. So in this case, what we are going to do is we'll look at the denominator. Okay, so when you talk of this type of limits, you just need to make sure that the denominator is not equal to 0. You just have to make sure that the denominator is not equal to 0. Why are we avoiding 0? We are avoiding 0 because according to rational function or rational expression rules, we have to know that when the denominator is 0, then our function surely becomes undefined. Okay, so for example, if you say 1 divided by 0 on your calculator, it will surely say math error. So that's one reason we avoid a 0 down there. Okay, now look at this question. The question is saying 3x minus 6 over x squared minus 4. So it is something that we all know, that we need to replace x with 2. Where there is x, we need to put 2. That's something that we all know, and that's something that we should all understand. Okay, so when I try to put 2 on the denominator, you're going to discover that when I put 2 on the denominator, my expression will be undefined, because it's going to be 2 squared minus 4, which is just 4 minus 4. And that means that this expression will have a denominator which is 0. That means that it will be undefined. So what can I do? So what I can do is to find a way I can escape this trap. So if you look at the denominator is different of 2 squares. And also if you look at the numerator can also be factorized. Okay, so let me quickly write down what I've just said. So the first step I've done is that I've factorized the numerator. So if you look at the question, you find that 3 is the common one on the numerator. 3 is the common number on the denominator. You find that the first expression, the first term and the second term, they can be worked on. Okay, so I factorize 3 out. So when I factorize 3 out, I'm going to have x minus 2. Okay, so this is the numerator which I've factorized. But let me quickly go down and factorize the denominator. So if I work out the denominator, guys, you find that it is a difference of 2 squares. What does that mean? This expression can be written as x minus 2 brackets x plus 2. That's what I've done. Nothing important there. But all I've understood is that we are using difference of 2 squares. Okay, I can see a comment that you can't get me. Is everyone affected? Are you all able to get me or not? Do you have people who can get me? Okay, so I'm pretty sure you just have a problem. Your phone has some sort of problem. Okay, so the next thing we have to do is if you look at this x minus 2, and x minus 2 on the denominator, these two guys can be divided by. Okay, so those two guys can be cancelled. So I'm going to plug in that which I've just said. So what I've said is that if you look at this guy in red and that guy in red, they are common, so these guys can be cancelled. So when we cancel them out, what are we going to have? We're going to have something like this. Okay, we're going to have something like that, which is hidden down there. So when we work out, we are going to have something like that. Why? Because this guy in red and that guy in red, they have cancelled each other. Okay, so this one has gone into that one, yeah, like that. So we have this expression. So if you look at this expression which has just been simplified, you're going to discover that if you plug in a 2 there, this expression will not affect anything. The denominator will not be equal to 0. So I'm going to plug in a 2 I'm going to put a 2 there, of which the expression has become like that. So immediately you plug in a 2 there, this expression lim x approaches 2 has to disappear. You don't need to include it as you write. So some lecturers, some tutors, some teachers, they might not want you to include that, and once you include that, you discover that you might be penalized. Okay, all right guys, and then you just simply work it out, and when you work it out, you're going to have that as your final answer. Okay, do you have any questions from you guys? Any question? Do I have any question from you guys? Please, if you have a question, kindly comment so that I know. Kasonde, do you have a question? Right, Mapalosh is okay. Kasonde, are you clear?
I can't see the screen.
You can't see the screen? How? But I can see the screen myself. According to my systems, the screen is being shared. Everyone can see the screen. Maybe you are on, there are 3 possibilities appearing in the meeting. So, not possibility, vision as lion. There are 3 vision as lion. One vision as lion is being used just for the audio, and the other vision as lion is sharing the screen. So you need to go on the one who is sharing the screen. Yeah. I'm sure that's where the issue is, unless if others are having issues. So, do we have anyone with a question? Anyone with a question? I'm sure no one. All right. That means that my explanation is all clear. So if you have a question, please unmute your mic and I'll be able to respond to you. And for those on Facebook, you can just simply comment. Okay. I think I've explained. Let me quickly go to the next question. Please make sure that you ask as many questions as you can. All right. So I'm going on the next question. So my next question, which is question 2, it is lim x approaches 3. So that also means that we are approaching 3 from the left and the right. We are approaching 3 from the left and the right. So make sure that you understand that. So since we are approaching 3 from the left and right, it simply means that our limits, whether from left or right, it is 3. That's our final point, or that's the point we can't pass. Okay, so just like I said, for these guys, you just have to make sure that the expression doesn't become undefined. Okay, sometimes you find that it can be a radical expression. So if it is a radical expression, you need to make sure that the inside, okay, the inside of the square root is not less than 0, meaning it is not negative. Okay, and then in a case of rational expression like this one, you just have to make sure that the denominator is not equal to 0. Okay, so let me quickly work it out like the way I worked out. So if you look at the numerator there, if you look at the numerator, this is a polynomial. Okay, if you look at the numerator, it is the polynomial. So since it is a polynomial, we are going to factorize it. Okay, so I'm not going to go through the steps of factorization because I have explained, or I'll explain in my other classes when I'll be dealing with factorization of polynomials, solving equation involving polynomials. So when I reach that part, I'll make sure that I explain. But in the meantime, I'm not going to explain that step. So let's quickly factorize the numerator. So if we factorize the numerator, this is what we are going to have. We are going to have x minus 3 and then x squared plus 3x plus 9. Okay, so I have factorized the numerator using synthetic division or long division. You can use those two methods to work out this. Okay, so from there, guys, if you observe down there, you find that this is a difference of two squares. It can also be factorized. Why are we doing all this? We are trying to make sure that this expression doesn't get affected when we plug in 3. So if I work out that one, we are going to find that this is how it will look like. Okay, this is how it will look like. So we are going to have x minus 3 x squared plus 3x plus 9. Okay, and then over x minus 3 x plus 3. So this one, we have factorized the denominator using the difference of two squares, and then the numerator, we have used the polynomial. So we can either use synthetic division or long division to factorize the polynomial. Okay, so if you look there, you find that this x minus 3 and x minus 3 can be worked on. X minus 3 and x minus 3 can be worked on. They're just the same. So like I have said, let me try to plug in that and see what we have. So the same thing that we have. So as I've said, those two are the same. So that means that those guys in red, they'll go. Those guys in red, they'll go. So when those guys in red cancel each other, what are we going to have? We're going to have that expression. This is the expression we are going to have, which is x squared plus 3x plus 9 over x plus 3. Okay, x squared plus 3x plus 9 over x plus 3. So let me quickly check out our friend on Facebook if there is anyone with a question. I don't know you guys or who are in the meeting. Is there anyone with a question? Anyone with a question? Anyone with a question? All right. No one with a question. Okay, cool. Where? Which part of on top?
Like here where you write x minus 3x, like yes, the same part.
This one.
Yes.
This x minus 3 brackets x squared plus 3x plus 9, it is coming from when you factorize x cubed minus 27. This is a polynomial. So this is a polynomial. So since it's a polynomial, you use synthetic division or you use long division methods to work out that expression. So I use those two methods, or I use one of those two methods to find that numerator which has just been factorized. And then the denominator here is a difference of two squares. if you look at this one, this is more like x squared minus 3 squared, because 3 squared, it is 9. So when I factorize that one, it gave me this one down there. So I'll factorize both the numerator and the denominator. Then from here, I went down there. So if you look at this one and that one, they are the same, which I have highlighted in red. So this one and that one will cancel. This one and that one will cancel. When this one and that one cancels, you are going to have that expression which is down there. Is it clear now?
Yes.
All right, thank you. So do we have any other person who has a question? Any other person who has a question as I check up on comments? Okay, I think no one. All right, let me quickly go on the next step. So the next step, everything is okay. So the next step, what you just need to do is to plug in a 3. You plug in a 3 where there is x. You plug in the 3 where there is x. So when we plug in a 3 where there is x, this is what we are going to have. We plug in a 3 where there is x, this is what we are going to have. So we are going to have 3 squared plus 3x plus 9 over 3 plus 3. Okay, so when you work it out, you're just going to have my purple answer. So that answer in PEP, it is the one which is our final solution. Do you have any questions so far before I go on the next question? Any question? The people from Facebook. All right, people from Facebook, they are all clear. Okay, I'm sure we are all settled with this. Since we are all settled with that, that means that we are all fine and okay. Okay, so the next thing I'm going to do is I'm going to go to the next part, which is the second question. Let me quickly go up. Should be the second. This is the second. So I'm sure it is the third question. Okay, so we have reached at the finite type. So when you look at the finite type, how we approached the first question is totally different from how we are going to approach the first question. Okay, two different things that we are going to do. So if you look at this, this is what you're going to discover. I'm going to give you the key thing to take note. Why don't I simplify the last? You can simplify it. It depends on what you want. Personally, I want it to just be like this. If you want, you can simplify it. It goes whereby you say 27 divided by 3 and 6 divided by 3. It's up to you. Yeah. Then here's the key. So the key when solving finity limits is that you need to know what I'm going to write in this box of mine. Okay, so this is the key of solving finity limit. So you need to understand that the key of solving finite limit is that lim x approaches finity of 1 over x is equal to 0. Okay, so this is the key that you should all take note of. So as you solve, you need to make sure that you put in mind that you should look for a way you can have 1 over x, 1 over or 2 over x, 3 over x, all that. So it has to be in your mind. So let me quickly also explain what that means. So that simply means that the limit of x squared, the limit of 1 over x squared is 0. the limit of 1 over x squared is also 0. Okay, and then the limit of, let's say, 1 over x cubed, I wrote x squared there. It was a mistake, but it has to be x cubed. Okay, so let me just quickly write there x cubed. So if I tell you have a limit of a 1 over x cubed, 1 over x to the power 4, 1 over x to the power 1 billion, all of them, their limits, so long you're approaching infinity, they are always equal to 0. Okay, so let me quickly go to our example. So our example is lim x approaches infinity of 2x cubed plus 1 over 2 plus x minus 3x squared. So the key, as I have said, for this type, the key is this one. This is your key. Okay, so what are we going to do? So what we are going to do, I'm going to rearrange the denominator. So let me quickly rearrange the denominator. So when I rearrange the denominator, this is what I'm going to have. When I rearrange the denominator, this is what we are going to have. So we're going to have negative 3x cubed plus x plus 2. Okay, so from here, what I'm going to do is I'm going to factorize x with the highest digit, the highest degree, not the highest digit, x with the highest degree. So the x with the highest degree on the numerator, it is x cubed, and also the denominator, it is x cubed. So what I'm going to do is just something simple. What I'm going to do is I'm going to factorize the x cubed on both the numerator and the denominator. I'm going to factorize the x cubed on both the numerator and the denominator. So if I do that, this is what I'm having. So if I factorize this guy here, this x, which is here, so let me just quickly highlight it for someone who need to see it. So this x here has been factorized. So this x here has been factorized. The x cubed has been factorized. So I've just factorized the x cubed like that. Okay, so when I factorize the x cubed, this is what I'm going to have as my expression. So I've not done anything, I've not done any change to the expression, because when I multiply x cubed times 2, it will be 2x cubed, and x cubed times 1 over x cubed, it is just 1. And then when I do the same thing to the denominator, I'm going to discover that I'm going to have the denominator down there. So this aspect, it's the same thing we do with complete the square method. It's just that complete the square method, we factorize a number. But in this case, we are just factorizing the variable. Okay, so let me quickly write it down and go to the next step. So my next step, you find that x cubed and x cubed, they are common. So x cubed and x cubed can cancel. X cubed and x cubed can cancel. So when x cubed and x cubed cancel, this is what we are going to have. When x cubed and x cubed cancel, that is what we are going to have. So we are going to have this expression. So this expression is just the simplified version of the first expression. So this has just been simplified. Okay, so from here, if you look at this point, it is now the same as what I gave you. Okay, at this point, that's when now you can use the key. Okay, so this is the point you can now use the key. So you plug in where there is 1 over x squared, 1 over x cubed, 1 over x. You plug in a 0. You plug in a 0. Okay, so if I plug in a 0 there, I plug in a 0 there, I plug in a 0 there, what I'm going to have, it is that expression which I'm about to write down there. Okay, I'm going to have 2 plus 0 and then over negative 3 plus 0 plus 0. As I've said, once you plug in zeros there, you plug in zeros there, or a number, you need to make sure that this lim symbol disappears. Okay, so that's all well and good on my side. I don't know about your side. I just hope you guys are really following up. Okay, so from here, ladies and gentlemen, what we can do is just simply work out that, and when we work it out, you know, 2 plus 0, it is 2, and negative 3 plus 0 plus 0, it is